let's now finish by Europe with Ari Pouttu. Ari is a professor at the Oulu University. I just mentioned that last year we had the EU CNC European Conference in Oulu with a great participation, involvement of Oulu University. So please, Ari, give us the vision of Europe on this topic.
Thank you. Well, I will basically talk about the Brazilian use case. So sorry. How to do that is I will go through with an example a Brazil EU project called 5G range. And you can see what this 5G range means. It's a remote area access network for the 5th generation. So this is one of the first projects within the 5G realms that actually start to look at the solutions required to actually affect the standards of 5G in remote areas. So basically, as was mentioned, agriculture is very important in Brazilian business, but of course remote can be other businesses as well, and people living in remote areas. I come from Europe, in particular from Finland, and in Finland we have very remote areas. You go beyond the Arctic Circle and there is nobody there. Well, there are a couple of persons and a lot of reindeers. But still these guys need the 5G who live up there. There are mining business that might need these remote area capabilities. So there are a lot of use cases that actually can use the remote option of 5G. But as mentioned, this is an EU-Brazil project, so let's go with the agricultural use case and bear in mind that this can be then used in other use cases as well. The numbers have been given already in many talks. A lot of people still unconnected. And so now when we go to remote areas, and now we are talking especially about the terrestrial part of the network. As mentioned by previous speaker, the backhauling is a very big issue, of course, and satellite is a very good candidate for backhauling solutions, especially now that the satellite community has been very aggressively putting new features into the 3GPP to standardize the satellite in 5G. So, what are the challenges? Well, sparse population, of course, few subscribers per square kilometer. Then, when we go down in the frequency, you start to see, due to the distance and due to the frequency propagation characteristic, you start to see channels with large delay profiles, double dispersive channels. And of course, the link budget is always a challenge when you want to have reasonably high data rates at great distances. And hence the cost reduction is mandatory. So there are several cost-related issues that need to be thought. There was the backhaul was one. The equipment itself needs to be really relatively cheap, at least. And then one thing that is always the big issue is the spectrum and the cost of the spectrum. And there are two ways around this problem. The first is what we use here, is to go and use cognitive radio in, for instance, TV white spaces. So this project is targeting that kind of approach. The other approach, of course, is then, which is already adopted in some countries, for instance in Germany in 3.5 gigahertz frequency auctions, that there will be a sharing-based frequency band where you can then exercise dynamic local micro-licensing if you wish. So these two approaches are available, at least in some countries which have adopted the sharing-based approach for at least for some of the bands. So the targets that the project has are threefold. First of all, the large coverage. And our target for cell size radius is 50 kilometers. So there was the size of the big farm, I guess, was the motivator for this one. The broadband connection, so relatively high data rate, so 100 megabits per second at the cell edge. And some mobility support, up to 120 kilometers per hour. So allowing for cars, trains, harvesters, and drones, etc., to be included into the realm of this remote 5G. So, what do we use as resources in this project? First of all, it's the TV white spaces. The good part of it is that since we go really down in the frequency, we do get the best possible available propagation characteristics. Then you use the cognitive radio principles to find out TV white spaces and use your signals in those particular vacant bands as secondary user. And you have to, of course, employ a spectrum sensing and database. There are some incumbents, of course, the TV stations. And then a little bit more challenging part, at least in engineering field, is then the waveforms. Because of we go down in the frequency, you need to have several things. You need to be able to have high spectrum efficiency in double dispersive channels, so in time and in frequency you have dispersion. And then you need to have extremely good spectrum localization, so that your signals do not leak to other frequencies, since there are a lot of systems adjacent to you, so you need to really contain the signal into the frequency in use. And the third part of the problem is that you have fragmented spectrum available, so you need to use different parts of the spectrum to combine into one signal. So for the waveform, as I already mentioned, we need low out-of-band emission and high spectral efficiency to get the 100 megabits at the cell edge, because we do not have a lot of spectrum available at the lower frequencies, because it's vanishing into zero when you go down to DC. So you have to play very carefully with the frequency. And you need to have a signal that is robust against this time and frequency distortions. And then on the cognitive and MAC layer, you need to have the spectrum sensing, dynamic spectrum allocation policies, and fragmented carrier aggregation, as mentioned already. And then some range enhancements are required. So this was about this 5G range. And Inatel is already building a demonstrator, or is it already finalized? So that I don't know whether you can see it during these days. It's outside. Excellent. So if you want to see the world's first 5G remote radio, go check it outside. But then there already been a couple of warnings that there might be some 6G prophets around here, so I have to acknowledge that I am one. Now here comes the rotten herring, the 6G. Of course, it's not time to talk about 6G business, but it's time to talk about 6G research. And in Finland, we started just recently this 6 Genesis flagship program, which is targeting whatever you want to call the one more G. It necessarily is not 6G, but it is something that comes after 5G. So when a new G starts, it starts with the research. So 5G research was started at our university in 2009, and now we are in 2018, so almost 10 years. So I would expect that this will take longer, and we probably see whatever comes after 5G, we will see it in 2030s. So it's a good time to start the research nowadays. And these are the first topics that we are looking at the 6G program, going to sub-terahertz and even terahertz frequencies to support wireless connectivity also in the terabit region, but really going down on the latency to hundreds of microseconds to support 1000 hertz control loops in factories. Then we start to have really interesting problem with devices and circuits, since now the antennas are becoming smaller than the electronics. So there are a lot of issues to be studied there. New materials may be required so that the circuits actually operate. Then in the distributed computing, a lot of computing is required everywhere, going even into the devices. And one of the things that is going to happen, and it's going to happen with 5G already, is that this AI inspiration will go through the whole protocol stack, and it will be everywhere. But the current AI algorithms are not very well suited for this dynamic birth-death data type of situation. So new AI solutions need to be devised so that we can live with the dynamic data. And then, of course, the services and applications, AR, VR, you name it, XR, they are coming everywhere, and then we look at the possibilities to use them in different verticals. But also these disruptive value models or value networks need to be studied and proposed strongly. You have heard the words private networking. You will, in the coming years, probably hear terms like vertical specific service provider. And these are the kind of guys who actually can make these verticals come into play in the 5G networks. The problem with verticals, apart maybe from automotive, is that they are really old-fashioned. It takes a generation to get these guys in. At least what I've been talking to different people. For instance, you go to a electricity utility company at their development department, and they say, no, wire is excellent. So it takes some time before we can get all the different verticals on board. Some of them are moving faster, but most of them pretty slowly. So therefore, yet another reason why we need something after 5G, because it takes time. And then one more slide. I would like to invite you to come to Finland in late March. And we are actually collecting a group of individuals who are interested what comes after 5G, and to come and define with us what are the initial requirements for whatever the 6G is, and what might be the candidate technologies. So please join us in Levi. It's a very beautiful place. You see winter, and this is a summit hotel. I mean, it's in the summit. So there you go. Thank you very much.